All right, so hi everyone. Myself Ayush Anantarpathi, and currently I'm working as a software developer at Delivery. And welcome you all to this post contest analysis of last weekly contest 199. So hope everyone has enjoyed the contest, and just do let me know if I am audible and how many problems you were able to solve. Okay, hi Varun, and also rate the entire contest on a scale of 10 so that we can improve the upcoming problem set. All right, so let's just quickly start with the first problem. So hope the screen is visible to you all. Let me just change the template. Maybe this one. And yes, it seems good to me. So starting with the first problem. So starting with the first problem, you are given an integer array ARR of size n, and you need to return the maximum possible score after applying n by 2 operation, and we have to take the floor value of n by 2. So basically if the value of n is 5, then you can only apply 2 operation. If the value of n is 6, then you can apply 3 operations n by 2 and take the floor value. And in one operation you can select any two elements a and b from array ARR, and then you have to add the absolute difference, their absolute difference in your absolute difference in your score, and then remove a and b both from the array. So let me just quickly discuss this first example. So here, to have the maximum score, what I can do, in the first operation I select this 2 and 8, then we remove this 2 and 8 from the array, and we'll add their absolute difference in my score. In the next operation we select a 3 and 7. These are the two elements which we are left with, and then this will be my score. Their absolute difference will be my score. We simply add 4 in my score, and then remove these two elements. Now the array is empty, and what will be my final score? My final score is 6 plus 4, which is equals to 10. So now let's see how we can discuss the solution. So in this problem we have an array. We have an array of n elements. So let me write the values. So let's say we have an array of 7 element, 7, 8. Let's say then we have a 2, 4. Then let's say 5 and 0 and 6. Or instead of 6, let's say we have some other number. Let's say we have 12. So the idea here is to first sort the array, and in each operation we select two integers. Select two integer. Let's call this as a and b. Select two integers a and b from array ARR. Select two integers a and b from array ARR, and then your score will be incremented by absolute difference of a and b, right? And at the same time you need to remove a and b from array ARR. So this was all about the operation. And how many operations we can perform? We can perform n by 2 operation. N by 2 operation, right? And make sure to take the floor value. Here the value of n is equals to 7. We have an array of 7 elements. So the idea here is to sort the element, because we want to maximize the score. At the end we want to maximize the score, and every time what we add in my score, every time we add an absolute value. We add an absolute value of A and B, absolute difference of A and B. So on a number line, we want both the integers A and B as far as possible. We simply want both the integers on a number line as far as possible. That's why the first step is to sort this array and then select the element from the left and one element from the right. So yeah, this is the idea. So first I will sort this array. So sort array ARR. Let's call this as array ARR. So sort this array ARR, and after sorting, what we will get? So element is 0, then 2, 4, 5, 7, 8, and 12. Now after this, we simply in a first operation, I'm going to select these two integers, integer 12 and integer 0. That is one element from the left, another element from the right. Then we select these two integers, 2 and 8. Then in the next iteration, I will select 4 and 7. And since the size of the array is 7, so we can only perform 3 operations. N by 2 and its floor value, which is equals to 3. So we can only perform 3 operations. And these 3 operations will give you the best result. So hope the idea is now clear to everyone. That's the complete solution. And now let me show you the implementation. So here we have our implementation. First I have taken the size of the array. Then this is my score. Initializing the score with 0. Sort the entire array. Initialize variable I with 0 and j with 0. That is, declare one variable with the first index and another variable at the last index. Then every time we pick up the element at index I and element at index j, then increment I, decrement j. So this is the way how we perform n by 2 operations, and finally this will be my score, the maximum score that we can have. The time complexity will be n log of n base 2 because of this sorting. Clear to everyone? Just write a quick +1. Yes, no, anything? Write a quick +1 if the like solution is clear to you. Cool. Now coming to the next problem, which is unique node count. So this is also a fairly easy problem. So in this problem, Geek find out a unique tree in a dense forest. The tree consists of n nodes numbered from 1 to n, and each node has an initial length 0. Geek observe the tree for d number of days and record how the length of the node changes. So you are given an array which is a 2D array, and each element is a 1D array of size 2. ARR of I, 0 represent the node number which you have to select, and ARR of I, 1 will simply represent the length increased in that node or for the ith day. And for each day from 1 to D, you need to determine how many unique length are present in a tree. So let me explain you with an example. So I can explain you with this example. Yes, let me just explain with the first example only. So in this problem, first you have been given n number of nodes, and these nodes are numbered from 1 to n. These nodes are numbered from 1 to n. Then you will be given d number of days, some information for d number of days. There will be increase of a length on a particular node on the ith day. So d is nothing but representing the number of days, and you have an array of size d cross 2. You have an array of size d cross 2, and here arr of I comma 0, it will simply give you the node number on the ith day, and arr of I comma 1 will simply give you the length. On the ith day, the node with the given number, its length will increase by this given value length, right? And for each day, you need to find the number of unique length that we have in a tree. So for this example, here we have n is equals to 3. That is, we have a 3 numbers of node. So I can say node 0, or instead of 0, we have to start with 1. The nodes are numbered from 1. So node 1 is having length 0 initially, then node 2 is having length 0, then node 3 is also having length 0 initially. Then on the first day, the length of node 1 will increase by 5. The length of node 1 will increase by 5. So for d is equals to 1, on day 1, the length of node 1 will increase by 5. So this will change to 5, and rest of the nodes will have the same length, right? And here you need to output the number of unique length we would have. So I can say my answer. So this is nothing but my answer. So the number of unique length on day 1 is 2. Now coming to day 2. So d is equals to 2. So here in this case, the length of node 2 will increase by 2. So that is, the length of node 1 is 5. The length of node 2 will increase by 5. So now it is 5. Then the length of node 3 will remain as it is. Okay, thank you, Hemant. So here how many unique length we would have? So the number of unique length is 2. Now coming to day 3. So d is equals to 3. So the length of node 1, 5, and the length of node 1 will increase by 10. So the length of node 1 will increase by 10. So now the new length of node 1 is 15. Then length of node 2 remain 5. The length of node 3, it is remain 0. How many unique length we have? So we have 3 unique length. Coming to day 4. So on a day 4, the length of node 3 will increase by 5. So the length of node 1 is 15, the length of node 2 is 5, and the length of node 3 will increase by 5. So now it is equals to 5. How many unique length we have? So we have 2 unique length. And the expected output is same, 2 2 3 2. Now the thing is how we can solve this problem. The idea here is to keep track of a map and simply declare a map. So we can simply use a map to keep track of a length, and along with that we also use a array node. So we simply declare a node array of size n plus 1. Simply declare a node array of size n plus 1, and node of I will simply store length of ith node. It's a super straightforward length of the ith node, and we also declare a map to keep track of a unique length, or I can say the frequency of the frequency. So let's declare a map. Let's name this as a frequency. Then for every day, for every ith day, so I can say for I is equals to 0, and it goes till d minus 1. So we have an array ARR of size d, that is up to index d minus 1. On the ith day, what I will do, so instead of calling this as a d1, d2, and d3, let's say I is equals to 1, that is ith day, then I is equals to 2, I is equals to 3, and I is equals to 4. On the ith day, first thing which I am going to do, I am going to just simply remove this frequency. So I'm going to just simply remove this frequency from my map. So frequency of node of, so the thing is how to get this node number, how to get this node number. So the node number will be given by ARR of I comma 0. So let's call this as x. So x is equals to ARR of I comma 0. So the node number is x. So we simply decrement the frequency. So frequency of node of x. So the node of x is nothing but the existing length of node x. So we simply decrement its frequency, and since every time we take the size, my answer is nothing but the size of this map. So once the frequency of any key is equals to 0, then we simply remove that key value pair from the map, and this is a very trivial solution. So if frequency of node of x is equals to 0, what does it mean? We do not have any node with this length. We do not have any node with this length. So just simply remove this. So I can say frequency dot erase node of x. So we simply remove this key. We simply remove this key from the map, right? And after this, we need to update the changes. So the length of a node x. So node x, the length of node x will increase by ARR of I comma 1. So by this factor, we need to increase the length of node x and then simply update. So frequency of node x plus plus, right? Just simply increment the frequency. That is, we got one node with this length, right? And what will be your answer? So I can just simply say answer of I, it is equals to the size of a frequency array. The size of a frequency array. This is a basic property of a math. This is a basic property of a map. It will store the unique key. So how many unique length we have? So yes, that's the complete solution. Now what I can do, I can just implement this from the scratch. So let's just go and discuss the implementation. So the very first thing, I need a node array of size n plus 1. In my previous implementation, I have different naming convention. I did simply use some other name for the array. So that's why I decided to like implement this again. So create an array node of size n plus 1, because all the nodes are numbered from 1 to n, and initially the length of each node is 1. Then declare a map. You can also use unordered map. It's totally your choice. But there is some advantage and disadvantage of using unordered map. And personally, I would not recommend anyone to go for the unordered map. Then simply iterate over all the indexes of this array ARR, and also let me declare answer array of size d. We need to answer for all the day from 0 to, yes, we need to find the number of unique length for all the given day. So the very first thing, the node number, I can say x is equals to the node number. It is the x is the node number, which is ARR of I comma 0, and the node of x will simply store the existing length of previous length of node x. So first I need to remove this from the frequency array. So frequency map. node of x minus minus. And if the frequency become equals to 0, so if the frequency of node of x is equals to 0, then I need to erase this from the map. So frequency dot erase, and just simply pass the key. So the key is nothing but the length. So basically the worst case time complexity of unordered map is linear. But in case of a map, the worst case time complexity is logarithmic. So that's why I recommend to avoid this unordered container. And after this, node of the length of node x will increase by AR of I 1. And then we need to update the frequency map. So the new length of node x and the frequency of this key plus plus. Now answer of I is equals to frequency map and basically its size. And then finally return this answer. Finally return this answer. Okay, so here someone asking for explanation, but I don't think. Okay, so like, what explanation are you looking for? So let me check what I did wrong. So frequency of node x, if it become equals to 0, then we simply remove it. Okay, so here one thing which I have missed. So initially I need to update frequency. So frequency of 0, it is equals to 1. Sorry, it is equals to n. Because initially we have a n number of node with the length 0. So frequency of 0 is equals to n. Now we have the same output as expected. So yeah, successfully submitted. So here someone asking for the difference between unordered map and map. So see, the map container internally uses a red black tree and red black tree or AVL tree, and the worst case time complexity for the insertion, searching and deletion in a red black tree is logarithmic. But the unordered container like unordered set, unordered map, they internally uses hash table, and due to the collision in a hash table, the worst case time complexity is linear for the insertion, searching and deletion. So that's why I would always recommend to avoid these unordered container, because unordered set internally uses hash table, and for the hash table we have a hash function, so we might have some collision in a hash table which lead to the linear time complexity in the worst case. So yeah, this was the complete solution for the second problem. Coming to the third problem, and it's a fairly standard problem and super easy, I can say, if you know the little bit of dynamic programming. So binary string. So geeks love the number k, and he want to construct a binary string of length n. A binary string basically a string containing zeros and one only. However, C follows a special rule. Every occurrence of 0 in the string must appear as a consecutive block of length that is a multiple of k. So you must have a chunk of zeros of length multiple of k, that is a 0 into k, 1 into k, 2 into k, and so on. So you will be given integer n and integer k. Determine the total number of valid binary string that can be formed. And since the answer can be large, so you need to return the answer under modulus 10 power 9 plus 7. So for example, n is equals to 3 and k is equals to 2. The expected output here is 3. So n is equals to 2, n is equals to 3, and k is equals to 2. So let's just quickly first draw all the binary string of length 3. So what are the binary string of length 3 we would have? 0 0 0, then 0 0 1, then 0 1 0, the binary representation of 2, then binary representation of 3, 4, binary representation of 5, then binary representation of 6, and finally binary representation of 7. So here the value of k is equals to 2. That is all the chunks must have the length 2 into 0, that is the first multiple of 2, then 2 into 1, then 2 into 2, and so on. So basically the occurrence of 0, the consecutive occurrence of 0 must have a length either 0, 2, 4, and so on. So here in this case, just tell me one thing, whether it is a valid or not. It is not valid. It is not valid because here the consecutive occurrence of 0, it is 3, which is not a multiple of 2. So it is not an valid string. Here we have a consecutive occurrence of 2 with the length consecutive occurrence of 0 with the length 2. So it's an valid string. Here we have a consecutive occurrence of 0 with the length 1 and 1. So it is not valid. It is not a multiple of 2. Then here we have a consecutive occurrence of 0 with the length 1. So it is also not valid. This one is valid. The length of the block is 2. Here the length of a block is 1. So not valid. Here in this case, the length of the block is 1. So again not valid. It is not a multiple of k. Then here the length of the block is 0. We have a 0 occurrence of character 0. So again this one is valid. So in total we have a 3 valid string. So that's why the expected output here is 3. The expected output here is 3. And yes, these are the 3 binary strings. So I hope the problem statement is clear to everyone. Now coming to the solution. So the very first thing, to solve these type of problem, there only exist two possible solutions. To solve all such problem where you need to count the number of ways or count the number of binary string, there only exist two possible solutions. Either you come up with some math formula, that is, you will claim that my answer is some function of n. This function of n can be any mathematical function, any linear, quadratic, any function. It might be possible when your answer is n power 3 or n cube n square or any function n into n log of n. So this is one way how to solve such problem. Another way is to write a recurrence relation. There only exist two possible solutions for these type of problem, and for this particular problem I won't be able to find any mathematical formula which represent my answer. Now we are left with a recurrence relation. So let's just find the recurrence relation. So the first step is to find the recurrence relation is to define a state, that what your function will return. So let's say define a state f of n. So f of n will simply return me the number of valid binary string of length n. The number of binary string of length n which is valid. And whenever I say valid, so it simply means the length of all the block of 0 is a multiple of k. All the blocks which are having character 0, their length will be a multiple of k. So this is what I mean by a valid string. Valid string which satisfy the constraint. Now let me just quickly discuss with this one. So basically we need to generate a binary string of length n, right? We need to generate a binary string of length n. So just simply explore all the possibilities which you have. So we would have n indexes, right? We need to generate a binary string of length n, right? So we would have n indexes. Now let's just start filling the values. So what are the options we have? So to have the resulting binary string valid, I have two options. Either I place a 1 here, right? If I place a 1 here, then just simply tell me the number of valid binary string of length n minus 1, and I just simply place 1 here. So this is one possibility. So let me just quickly copy this thing. The one possibility here is that just simply place 1. Just simply place 1. Just simply place 1 here. If you place 1 here, then this will be the remaining length. This will be the remaining length which you need to fill. Right? Another possibility is to place a 0. Either place 1 or place a 0. But if I place a 0, now I am restricted to place the number of zeros which are multiple of k, which is a multiple of k. Right? So now I am going to place k zeros here. Now I am going to place k number of zeros. Now let's say the value of k is equals to 3. Let's say the value of k is equals to 3. So now I am restricted to place at least, I am restricted to place k zeros here. Not at least, but multiple of k. So I am restricted to place k zeros here. Now this will be the remaining length. So here the remaining length is n minus 1. Here the remaining length is n minus 1. And in this case, the remaining length is n minus k. Right? So we have only these two possibilities. So I can just simply say f of n is equals to f of n is equals to f of n minus 1 when I place a 1, and if I place a k consecutive zeros, then the remaining length would be n minus k. So just simply tell me the number of valid binary string of length n minus k. So this will be the recurrence relation. This will be your recurrence relation. Now here, what would be my base case? So f of 0, just simply tell me the number of valid binary string of length 0. So length 0 basically means an empty array. Length 0 basically means an empty string. So empty string is also valid. Empty string has a 0 occurrence of 0, and 0 is a multiple of k, right? 0 is a multiple of k. So we have a 0 occurrence of 0. So it is a multiple of k. So yes, it is also valid. So an empty string is also valid. So I can say there is only one string. Now you know the recurrence relation, you know the base case. Just simply go and implement the solution. And it is clearly visible that the problem is having some overlapping subproblem. So we simply memorize all the answer. That is simply use the dynamic programming. Now let me explain you with an example. So n is equals to 3 and k is equals to 2. I'm going to explain with the same example. So f of 3, we simply call this function f of 3. So for f of 3, f of 2 and plus n minus k, that is f of 1, right? And f of 2 is equals to f of 1 plus f of 0, right? And f of 1 is equals to f of 0, because here n minus k is not possible. Here 1 minus 2 is not possible, right? So basically we all know that f of 0 is equals to 1. That is an empty string. An empty string is valid. It has a 0 occurrence of 0, which is a multiple of k. Now f of 1 is equals to 1. So it simply says that just simply add 1 in an empty string. So just simply add 1 in an empty string, and this string is valid. It has a 0 occurrence of 0, which is a multiple of k. So it is a valid. Right? It is a valid. Now let me just quickly change the color. So maybe with the blue. So it is valid. Now here f of 2 is equals to f of 1 plus f of 0. So what does it mean? So f of n minus 1. This n minus 1 is called when I place a 1 at the front. So it simply says, it simply asks, just simply tell me the number of valid binary string of length 1. So we all know there is only one binary string of length 1 which is valid. This is the binary string of length 1 which is valid. And in a front of it, I just simply place 1. Now we have a binary string of length 2 and it is valid. Now the second thing which I am asking, just simply tell me the number of binary string of length, just simply tell me the number of binary string of length 0 which is valid. So we all know empty binary string is valid. So in a front of it we simply add two zeros. We simply add two zeros and now it is a valid. Now it is a valid binary string of length 2. Cool. And after this we call a function for f of 3. So f of 2 is equals to, it is 1 plus 1, or yes, f of 2 is equals to 1 plus 1, which is 2. Now the value of f of 3, what will be the value of f of 3? So f of 3 is equals to f of 2. What is the value of f of 2? So f of 2 is equals to the binary string of length 2. F of 2 is equals to 2 and f of 3 is equals to f of 1 is equals to 1. So 2 plus 1, which is equals to 3. So this simply means there will be 3 binary string of length 3. Now how we get this information? So f of 2 is equals to 2. That is, there will be two binary string of length 2. So this is 1 1 and 0 0. And in front of these two binary string, just simply append 1. Just simply append 1. Now the length of the binary string is 3 and it is valid. Now tell me the number of binary string of length 1. So there is only one binary string of length 1 which is valid. Simple one. Simple one. And in front of it, we simply added two zeros, and now this binary string is valid. And you can see this is how we build the answer, and these are all the three binary string of length 3 which is valid. So yes, this is the complete solution. It has some overlapping subproblem, so just simply memorize the answer. Now coming to the implementation, here we have a constant integer mod 10 power 9 plus 7. Then we have our dp array. Then dp of 0 is equals to 1. Iterate over all the integers. dp of I is equals to dp of I minus 1. And if I is greater than or equals to k, just simply add the value of dp of I minus k, and every time take a mod, and then simply return dp of n. Clear to everyone? This solution. Write a quick +1 if it is clear to you. Now coming to the next problem, last problem of the contest, which is a count base. This is also a fairly interesting problem. So in this problem, you are given two arrays A and B of the same length. Given two arrays A and B of the same length, and you can perform the following operation on array A. Just to choose array index I and increase or decrease the value of A of I. And you have to modify array A with the minimum number of operation so that the difference between every adjacent pair of elements in A matches with the corresponding difference in B. That is, after performing the operation, the following condition need to be true for all the indexes from 0 to n minus 2. A of I plus 1 minus A of I, it must be equals to B of I plus 1 minus B of I. And your task is to count the total number of different ways to achieve the goal using minimum number of operation. So the very first thing, you need to use the minimum number of operation, and then you need to tell the number of different ways to achieve this condition using the minimum number of operation. And since the answer can be very large, so you need to return the answer under modulus 10 power 9 plus 7. And if no operations are required, then return the number of ways as 1, which is self understood. So let me explain you with an example, with this example only. So the very first thing, after using a minimum number of operation, this condition need to be true. That is, a of I plus 1 minus a of I, it must be equals to b of I plus 1 minus b of I. This condition need to be true for all the values of I which is in the range from 0 to n minus 2, right? So I can just simply modify this condition, and this can be written as a of I plus 1 minus b of I plus 1, and it must be equals to a of I minus b of I. So what does it mean? So let me just quickly write this in a terms of array. So let me just fill this with the indexes. So index 0, 1, 2, 3, and so on up to index n minus 1. So this is my array A. Then this is my array B. Now here I modified the condition, and now I know all the indexes must have the same difference. That is, A of I minus B of I must be same for all the indexes. At here we must have the same difference. At all the indexes we must have the same difference. Cool. Now it's a pretty standard problem, but you just need to come up with the come to that problem. You just need to boil down the solution, boil down the problem into a simple statement. So let's create an array B, or instead of creating an array B, let's call this as array D. So array D is a difference array. So D of I will simply store the difference of A of I and B of I. So D of I is equals to A of I minus B of I. Now this is my difference array. So this is my difference array, and D of I will simply store A of I minus B of I. And at the end, what we want? At the end, we simply want all the values to be same, right? Using the minimum number of operation. So I can write in this way, that is using minimum number of operations we just simply want all the values of array D must be same. That is D of I is equals to D of I plus 1, or I can simply say D of 0 must be equals to D of 1. Then D of 1 must be equals to D of 2, and up to D of n minus 1. So our goal is to make all the values of this difference array equals using minimum number of operations, right? And in each operation, you can just simply increment the value of A of I, or decrement the value of D of I. So if you increase the value of A of I, then your difference will increase, and if you decrease the value of A of I, then your difference will decrease, right? So in each operation, I can just simply either increment the value of D of I, or I can decrement the value of D of I. So let me write it this way. So D of I plus equals to 1, and D of I minus equals to 1 in each operation. And using minimum number of operation, I just need to change all the values I need to change all the values. I need to make all the values same. That's the simple funda, right? So this is a very standard problem. Very standard problem. If you have an array and if you want to make all the values same using minimum number of operation, and if in each operation you can increase and decrease any value by one, then it's always helpful to select a median, to find the median of an array, to find the median of an array, and simply make all the elements equals to the median. So let me give you an example. So the same example which we have. So here array A is 1, 4, 2 and array B is 1, 2, 3. Array B is 1, 2 and 3. So now what will be array D? My array D, a difference array, it is 0, then minus 2 and minus 1. 0, minus 2 and minus 1. So simply sort all these, simply sort this array D. This is the first step. The first step is to sort this array D. Sort array D and then select median. Select median. Select the median. And it might be possible when you have two medians, but if the size of the array is odd, then you would have only one median. So now here in this case, just simply sort this array D. So now array D is equals to minus 1, comma 0, comma. So here actually it is not minus 2, it is 2 only. Then 2. So now here in this case, the median is 0. So here in this case, the median is 0. So we make all the elements equals to 0. And how many operations do we require? So the number of operations do we require? Let's call this as a total. Let's call this as total. So the number of operations that we require, just simply iterate over all the indexes from 0 to n minus 1, and the number of operations which I require is the absolute difference of median and d of I. The absolute difference of median and d of I. So d of I minus this one median. This will be the total number of operations that you require, and it is the minimum total number of operations that you require. This is the minimum total number of operations that you require. So for this particular example, how many total number of operations we require? So the total number of operations that we require is minus 1, minus 0, the median is 0, then plus 0 minus 0, plus 2 minus 0. That is, here in this case it is 1 plus 0 plus 2. That is, in total we require 3 operations, and we simply perform one operation. We simply perform one operation over here, and we perform two operations over here. That is, we perform one operation at index 0, then we perform two operations at index 2, right? So how many permutations are possible? So how many number of different ways? So total ways are, just simply perform the operation, just simply perform the first operation at index 0. So perform first operation at index 0, then perform a second operation at index 2 and the third operation at index 2. Then second permutation, perform first operation at index 2, second operation at index 0, then the third operation at index 2 again. Then third way, perform two operations, first two operation over the index 2, then the third operation at index 0. So these are all the three ways. So the expected output here is 3. The expected output here is 3. And here is the explanation. So I'm not going to read this explanation. Cool. Now if I summarize this thing, we all know that we perform two operations at index 2. We perform two operations at index 2 and one operation at index 0. So 0, 2, 2. So all you need to find the number of unique permutations. So find number of unique permutations. Number of unique permutations. So we have a very standard formula of finding the number of unique permutations. Just simply say it is nothing but a 3 factorial, and divided by the frequency of all the elements. The size of array. If you want to know the number of unique permutation of this given array, consider this as an array. So consider this as an array. So the number of unique permutation is the size of this array, and divided by the frequency of the multiplication of frequency of all the elements. So here in this case, the size of the array is 3 factorial, and it is divided by the frequency of element 0, which is 1 factorial, again divided by the frequency of element 2, which is 2 factorial. The frequency of element 2, it is 2. So it is 2 factorial, which is nothing but 3 multiplied by 2 and divided by 2, which is equals to 3. Right? So in short, if I summarize this, then my answer will be total. This is a total number of minimum operation. This is a total factorial, and divided by the frequency of each element. So how to get this thing, frequency of each element? So just simply iterate over this array D, and it is nothing. It is nothing but the absolute difference of median minus D of 0, and this will give you the frequency, and just simply take a factorial multiplied by median minus D of 1, and just simply take its factorial. Just simply take its factorial, and so on. Median minus D of n minus 1, and just simply take its factorial. So this will be your answer. This will be your answer. Right? So I hope this is now clear to everyone. It's super straightforward, and it is a very standard formula. This is a very standard formula, and even this problem is very standard. Now there are some edge cases which we need to cover. So this is the case when we have odd number of elements. It might be possible when you have an even number of elements. So if you have even number of elements, then we would have more than one median. So for example, let's say your array D, it is equals to -5, then maybe 2, then let's say we have a 4, and let's say that we have a 3. So we have this array, or let me just quickly write some discrete values. Or yes, actually it is fine. So yes, this would work. So here in this case, first we sort the array. We all know the first step. The first step is to sort this array D, right? And then select median, right? Select median. And this time we have even number of elements. So after sorting this array, now this is -5, -2, then 3 and 4. This is the case after sorting. So now what are the potential values for the median? The potential values for the median, we have two medians. Let's call this as a left median. So the value of a left median, it is a D of n by 2 and -1, the value of left median. And the value of right median, it is equals to D of n by 2. This will be the value of a right median, and all the integers which are within this range can be your potential values for the median. So all the values which are in this range can be your potential value for the median. That is, this left and right are the boundaries. So left median, comma, right median. So we need to do this thing. We need to do the same thing for all the possible values of median. So in this case, the left median is -2 and the right median is 3. So the possible values for the median, it is a -2 to -3. Sorry, -2 to 3. So you need to iterate over all the values. So you need to iterate over all the integers. So we simply run a for loop. So let's call this as m. So it will start with the left median. So let's call this as lm. So I'm going to use a term lm, but lm means the left median, and up to rm, that is right median. And for every m, we call the function. We call the function and use the same formula, right? And why I'm saying this thing? So let me just give you some example. So let's just first consider median as -2. So if you consider the median as -2, how many total operations we require? So the total operation that we require is -5 minus 2 plus -2 minus 2 plus -2 plus 3 minus 2, 3 minus -2, which is equals to 3 plus 2 plus 4 minus -2. And here also we would have a plus sign. So it is 3 plus 0 plus 5 and plus 6, which is equals to 14, right? And now if you select the median, let's select the median as -1. So if you select the median as -1, then how many total operations we require? So it is -5 minus 1, which is a -5 plus 1. So -5 plus 1, then -2 plus 1, then here it is 3 plus 1, then 4 plus 1. So in total it is equals to 4. It is equals to 4 plus 1 plus 4 and plus 5, which is equals to 14. Now you can see we got the same minimum number of operation. And if you check for all the median in the range from -2 to -3, then you will get all the median will require the same operation. So I need to consider all the medians, and we consider all the median which are within this range. And for every median, we just simply find the number of ways. The number of ways to make all the elements equals to that median. And we all know what will be the total number of ways, total factorial, and divided by the number of operations, or I can say the frequency of each element. So let's say I need to apply 4 operations at index 0. Then let's say I need to apply 3 operations at index 1. Let's say I need to apply 0 operation at index 2, and let's say I need to apply 1 operation at index 3, and let's say 2 operations at index 4. So your answer will be total, and here the value of total is nothing but the sum of this array. Consider this as an array. So 4 plus 3 plus 1 plus 2, which is equals to 10. So 10. So your answer will be equals to 10 factorial divided by 4 factorial multiplied by 3 factorial multiplied by 1 factorial and multiplied by 2 factorial. This will be your total answer, and it's a very standard formula. So yeah, that's the complete solution for the last problem. Now coming to the implementation. So here we have a constant mod 10 power 9 plus 7. Then here I have taken the integer. Here I have declared an integer, static integer 10 power 5 plus 5. But the constraints are pretty small, so you can declare this array, this integer up to 10 power 4 only. Anyway, that this is my power function, and it will return me the value of a to the power b in just log of b time. So this is nothing but a binary exponentiation function. Then addition under modulus, then subtraction under modulus, multiplication under modulus. Then here we find the inverse, then division under modulus. So basically here I simply use a Fermat-Gödel theorem, which give you the inverse. And then this one, this is a pre-computation for the factorial. To find the factorial, I have a pre-computation. Then this is NCR, but actually it is not required. Then this is a function that you need to compute. So here I call the utility method to pre-calculate the factorials. Then taken the size of the array. Then this is my array difference array, right? This is my array D. Just simply sort this array, and your left median. This is your left median, and initializing the right median with the same value. And if the size is even, then the value of left median would be t of n by 2 minus 1. And initializing answer with 0, iterate over all the median, in the range from left median to right median, and let's call this as k. And then I will call the function number of ways, and it will return me the number of ways for a particular value of a median, or I can say k. And then I will simply add this in my answer and under the modulus, and finally I'm returning my answer. So here we have our number of ways function, or I can say method, for a particular median, taken the value of n. Then here we have our variable total and answer for the current median. Then I iterate over all the indexes from 0 to n minus 1. Then this will be the difference of I. The simply update difference of I by taking the absolute value, by taking the absolute difference between the median and difference of I. Then I'm adding this in my total variable. Now my answer is equals to total factorial divided by the frequency of each, and the frequency of each will be given by this thing. And finally I'm returning this answer. So yeah, that's the complete solution. Let's just try to submit this. And yes, successfully submitted. Cool. So this was all about the all the 4 problems, and the time complexity here is up to 10 power 4, not more than that. So if there was something which is not clear to you, then you can go and watch the recording of the session. So hope you have learned something new, and also I'm interested to know your feedback. So just do write your feedback in the comment box so that we can improve the upcoming post analysis. And hope you have learned something new. So do hit the like button, and thank you so much everyone for joining this live stream or watching the recording of this video. And have a good day. Good night. Just do let me know if you have any query. So I guess no doubt so far.